Hello everyone, I am Raj and let's look at today's problem on CSES factory machines. A factory has n machines which can be used to make products. Our goal is to make a total of t products. For each machine, we know the number of seconds it needs to make a single product. The machines can simultaneously work and you can freely decide their schedule. What is the shortest time needed to make all the t products? So we have given input where we are given on first line n and t the number of machines and products. On second line we have given n machine time needed to make a single product, and for output we have to print minimum time to make t products. On constraints we have given n up till 10 to the 2e5 and t up till 1e9, k up till 1e9, and we have given a sample test case where we have shown how this output has been came. Now let's look what our problem is telling. So we have given n machines, m1, m2, up till mn, and for each machine we have given k1, k2 up till kn. This is telling time to make a single product with this machine, means this machine can produce one product in ki time. So we have to make minimum of tea products, and for to make this tea product we have to find minimum time, in how much minimum time we can make this product. Let's say that it is time t dash. So we have to find minimum time t dash such that we can make all these tea products. Now let's look our brute force approach. What we can do in brute force is, first of all, what we can do is iterate for t is equals to 0 till what can your case is the minimum time to make all these products is t products is at max t can be 10 raised to power 9, and for, if let's say one machine is taking at minimum of 1 second, so at max t can go up till 10 raised to power 9. So it can go up till 10 raised to power 9, and we can do t plus plus. Inside this, what we can do is just run another for loop for all n machines for j is equals to 0 till j is less than n, and just take a sum variable, and what we can do is sum plus equals to t divided by k of I. Now how this formula came, let's say if we are looking at our current time t, and we can make t by ki products in this much time for ith machine. So this brute force solution will give us correct answer in big O of n into 10 raised to power 9, which will be nearly about big O of 10 raised to power 14 iterations in 1 second. Now we know that in 1 second we can do at max 10 raised to power 8 operations. So now let's see how to optimize this. We can see and we can intuitively think that we can't reduce our this big O of n, but we can reduce our this big O of 1e9, because what we are doing is we are linearly going from time t is equals to 0 till time 1 is time is equals to 1e9. Now, as we know that time is continuously increasing and we have to find the minimum time, so this function will always be monotonic. Means at some time it will be false, 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 and then true, 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 true. So we have to find this first true where this function will give true. Our predicate function will give true. Now, how this function is monotonic? Because let's say if we are taking time tk and we have time tk plus 1 dot 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 and time tk minus 1. Let's say tk minus 1, tk minus 1. Let's say this is our answer. If this is our minimum answer, so this can't be our answer because further going minimum will be useless and senseless. So that's why if this is our minimum answer, then we can't go left to it. We can only go right. And if we are going right, so it also don't make any sense because if we are checking that how which time can give us minimum, so we can always say that this time will always give minimum because if we are moving further from this minimum time to maximum, so here always time will increase only, but we want minimum time always. That's why we take this first t value. Now let's look how we will optimize this solution. We will optimize this solution by binary search. So we will take our int low variable as 0 and int high variable as 1e9. Now why it's one why it will be 1e9? Let's say there are we have to make a total of let's say t is equals to 10, 1e9 products, and each machine is having only 1 second for a product. Means on 1 second it is making one product. So for this much product to be made, the total time and minimum time will be required is 1e9 only. That's why our high variable is 1e9. Now we will run a while loop where it will go from low to high. Inside this we will take a mid variable. Mid is equals to low plus high by 2. As we all know, it is standard binary search syntax. Now let's call a predicate function boolean. It will return a boolean return type or predicate function. After function is being written in boolean, we will check if our function is returning true or not. If it's returning true, what it means that we have made we have made greater than equals to t products in time mid in mid time. We have made this greater than equals to t product in mid time. So if we can make greater than equals to t product in mid time, so we can always make greater than equals to t product in this time also, and we can further check for more minimum time also. Means in predicate function, we as we don't know, as code don't know where we are, so it might be here, it might be here, so we have to check further. If here true is being written, so further we have to check for minimum, further we have to check for minimum, and once it will get false, so we have to check for maximum. And like this, when low will greater become greater than high, in that case we will always be here only. So for else case, we will do simply low is equals to mid plus 1. Now let's look at predicate function. In predicate function, what we will do is we will take MRR array of machines, and we will take int mid, where it will be our mid time, and we will take another variable as t. It will give at max we have to make t products. So what we will do is we will run a loop for int I is equals to 0 till I less than n and I plus plus. Similarly, as we have discussed in brute force, we will declare some variable and we will do mid divided by k of I. By this formula, as we have discussed, as in, let's say if mid is equals to 5, we have 5 seconds, and k is equals to 2. So how much product we can make in 5 seconds? Only 2 products. It will consume 4 seconds, and in one product we can make half product only. So we have don't have to take this, and we only have to take the products which can be fully made. So that's why only 2 products can be made, and it will add in some variable. At last, we have to check before returning is if sum is greater than equals to t. If it is greater than equals to t, then we will return true. Why? Because it is for sure that minimum of t products we have made, in this much time. Means we have to make at least t products, and we have made at least t products in mid time, so we have to return true. And if in the case this sum becomes less than t, in that case we have to return false, because we were unable to make the products at least t. So we are telling to our binary search that please increase our low variable to mid plus 1 and search for a bigger time value, so that it should give a true value. So let's talk about the time complexity of this code. So it will be big O of n logarithmic of 1e9, which will be nearly about big O of 30 into 10 raised to power 5, as n will be go up to 10 raised to power 5, and logarithmic of 1e9 gives at max 30 iterations. So it will give at max 3 into 10 raised to power 6 number of iterations, and which is far less than 10 raised to power 8 iteration, which we can perform in 1 seconds. So let's look at code now, how we are done this. So we have KRR, means the time for each machine to make a single product, and a T. We have defined a starting index as 1, and we have defined an ending index as 1e18. We can also define it as 1e9, but it doesn't mean that if we are making high as 1e18, means 10 raised to power 18, so it will not make any significant change, as because logarithmic of 1e18 will become 18 into nearly about 3 point something, so it will be nearly about 60 iterations. So our time complexity will become 6 into 10 raised to power 6, which is also far less than 10 raised to power 8. It's on our choice, we can take 10 raised to power 9 also, or 10 raised to power 18 also. And after that, we are running a simple while loop, as we all know how to do binary search, and we will take a mid variable. Then we will call a predicate function, and this logic has been discussed, as if predicate function is returning us true, means here predicate function is returning us the number of products. As number of products, it is returning as product pro. If it's less than t, then it means that false in our case, as we have discussed, and if product is greater than equals to t, then as we have discussed it should be true. So instead of returning a boolean return type, I have written in code just a number of products. Both can work, as we have discussed in our approach, that we can return a boolean value or also we can return this value, and we can check in our binary search here only if it is less than or greater than equals to t. If it is less than t, then we are telling to binary search, please increase your time limit, because we are unable to make at least t products, else we are able to make t products. So this can be our answer, or we can further go minimum to check. In predicate function, as we have discussed, we will take a sum variable, we will iterate from I is equals to 0 to I is equals to n, and we will do val divided by krr of I, where val is our mid value. Here I have taken val, it is our mid value which is came from here, and we are checking how much sum we can produce, and if sum becomes greater than equals to t, I will return sum. And after this, if we are unable to return the sum, this means that after whole iteration the sum will always be less than t and we have to return our sum. So I think you understood the problem, and it is also accepted on CSES platform. So thank you so much.